Hello!
Hello!
My name is Alonso.
And I'm Arleth Meza.
And today,
we're going to be talking about coral bleaching and the Great Barrier Reef.
we will be discussing several topics regarding corals such as the corals themselves, the polyps, zooxanthellae, mutualism, coral bleaching, and the effects it has on coastal communities, for example, the Great Barrier Reef.
So, stay tuned if you want to find out more.
AICE Marine Science Period 3.
Well, you don't really have a choice, but
Yeah.
whatever.
Cool.
Okay, so first we're going to be talking about the coral. Corals are animals that belong to the phylum Cnidaria. They have colonies of identical coral polyps, which makes it up. Within the polyps, they are individually built into the coral with calcium carbonate skeletons, and only in hard coral does it take billions to form a reef.
Cool. Thanks for that, Arleth.
You're welcome.
Now, as you can see as I'm drawing right now, those little dots actually represent something. Those themselves are the individual polyps. And here right now, I'm drawing a zoomed up image of it, where the little green circle stars are the coral polyps themselves, which are made up of calcium carbonate. Adding on to what she said earlier.
What I'm drawing right now are polyps. And within the polyps, as I stated before, they build up the coral reefs because of the calcium carbonate skeleton. And within the polyp, there's a mouth, and then the tips are the zooxanthellae that live within the coral tissue.
Cool. Now that we have a better understanding of coral polyps, let's move on to mutualism. So, mutualism is a type of symbiotic relationship. In corals, the zooxanthellae are found within the coral polyps themselves, usually within the tentacles and the tips. So a symbiotic relationship, specifically mutualism, occurs when between two different species in which both benefit from a type of relationship that they have with each other. So, the symbiotic relationship between the coral and the coral polyps, which, remember, do hold the zooxanthellae, is that the coral provides shelter and protection for the coral polyp, which in turn provides sugars such as C6H12O6. The coral also provides substances such as nitrates, so that way the zooxanthellae and the coral polyps can photosynthesize.
Thanks, Isaac, for all that great information that you gave us. Okay, now, class, we're going to be moving on to the conditions for coral growth. Wow, exciting, I know. Okay, so in order for corals to grow, they need plenty of sunlight, and they need to be in shallow, clear waters. And in order for them to grow, shallow and clear waters are necessary because they need sunlight to penetrate the water in order to reach them so they can do photosynthesis. And as Isaac is drawing right now, he's showing the appropriate temperature that the reefs need to grow, which is about 20 degrees Celsius to 32 degrees Celsius. And it can't go any higher or lower. And the pH at about 8.
Wow, thanks for that, Arleth.
You're welcome.
Now, as many of you may or may not know, a Great Barrier Reef is actually a barrier reef.
Wow.
The way a barrier reef forms is actually pretty cool. A deep underwater volcano has to emerge and break through the surface of the ocean water itself, which then generates an island. And on this island, specifically on the coastline, coral larvae begin to enter it and then grow into a fringing reef.
Due to the density of the volcano and density of the crust, this causes the volcano to submerge. And once the volcano submerges, the coral around it is left behind and continues to grow. And in the middle is the lagoon.
So, moving on to coral bleaching. Coral bleaching occurs whenever the conditions for a coral to exist in the ocean's waters are disturbed, and it makes it heavily distressed, which causes it to release the zooxanthellae. Kind of what happens to a senior during finals.
True.
There are multiple different ways for coral bleaching to occur. One of the main ones is through the introduction of nitrates through runoffs, which causes an algae bloom that covers the surface of the water, which makes it difficult for sunlight to penetrate through the surface of the water. A drop in pH making it more acidic can also occur from acid rain. An increase in turbidity through substances such as silt also makes it difficult for the sunlight's rays to pass through the surface of the ocean water, which makes it difficult for the zooxanthellae to photosynthesize. An increase in temperature is also not ideal.
A jumble of all these causes can not only affect the corals, but also the coastal communities around them.
In a negative way. Contrary to belief, whenever a coral is undergoing coral bleaching, it is not actually dying. What actually is happening is the coral is releasing the zooxanthellae from its polyps, which causes the coral itself to become a very pale white color. Hey, so Arleth, do you want to hear a joke? Okay, so coral bleaching, kind of like a senior, whenever they see that they're failing half of their classes, turns very pale.
Anyway, so like it's demonstrated in our drawing, if the coral is in a nice blue color and it turns into a white pasty color, these effects will happen to the coastal community. Productivity will lower, the biodiversity also lowers because the fish don't have any shelter or anywhere to live, and their food also goes down, as well as tourism.
As well as shore protection and erosion. Now it's time for the last part, guys. Alright, so the Great Barrier Reef itself is the largest barrier reef in the world, and it's actually able to be seen from space. Now, in the northern region, most of it was actually killed last year by overheated waters, and in the southern region, most of it was actually experiencing coral bleaching. The distress and death of coral reefs actually define the health of the sea. One of the biggest factors for coral bleaching occurring in the Great Barrier Reef is due to global climate change. And as many of you may or may not know, global climate change is responsible for overheating the water, typically above 32 degrees Celsius, which is the ideal temperature range for coral to survive in. Fortunately for us and the Great Barrier Reef, 9% of it managed to completely avoid coral bleaching this past year. And scientists have managed to find that if the ideal conditions were to occur, there could be a total or at least partial Great Barrier Reef recovery in just 10 to 15 years.
So are you saying we can still save the reefs?
That's right, Arleth. Now, this is only actually possible if certain conditions are met. And scientists are still figuring out if that's even possible, because most of the Great Barrier Reef, as of right now, is dead.
Thanks, Isaac, for letting us off on that very optimistic view, as always.
You're welcome.
And now, to end our video, we want to say thank you to everyone who was part of it, which was mainly just me and Isaac, and Jesus, who kind of helped, but kind of didn't. So, yep.
He had a really shaky hand. It was kind of unsteady, so that's why it wasn't stable.
Yeah, we'll just blame him for that.
Yeah, it was definitely his fault, guys.
Yep. Thanks for watching, and I hope you guys enjoyed it.
And if you have any questions, comments, or concerns, please keep it to yourself.
Please. We don't want to know.
Alrighty.
Bye.
Bye.
Do you think we'll get an A?
I hope we get an A.
I
mean, we did everything. He didn't have a criteria, but I mean, like, we did it. Wait, did he have a criteria?
I don't know. Oh, wait, still recording?
Hey, Arleth, do you care about coral reefs? 'Cause I don't care at all.